All right, so we're ready to try and set coefficients for that equation we had gotten to where 0 was equal to 2c2 plus the sum from n equals 1 to infinity of cn plus 2 times n plus 2 times n plus 1 minus cn minus 1 x to power n. So for this equation, we've got that relationship 1 is given by 2c2 equals 0. So we take what's outside the series and set it equals 0. And then that R2 is going to be taking what's inside the series and setting it equal to 0. So that's going to be a little longer. Cn plus 2 times n plus 2 times n plus 1 minus Cn minus 1 equal to 0. So I've done step 1 and identified my relationships. This first one is just going to tell me that C2 must be 0. And then the second one actually gives me a relationship that's going to be useful to me later. I can go ahead and manipulate it to solve for Cn plus 2 in terms of Cn minus 1. Just move everything over to the other side except for Cn plus 2. So I get Cn minus 1 divided by n plus 2 times n plus 1. So now is the part where I try to plug in n's until I have 2 unknown coefficients, and then I plug in more n's until I have a pattern for the rest of my coefficients. Remember, we always start from C0 because our series starts from n equals 0 when we first introduce it. So then for n equals 0, I'm trying to find C0, but this one requires that I knew something beforehand, C before me, and this one only tells me about C2. So this is one of those cases where I say, okay, I guess C0 is just C0. And then I can go ahead and keep going. I'm trying to find C1, but this one only tells me about C's that came 3 before me, and I don't have that many yet. And this one only tells me about C2. So again, I'm just going to say, okay, I guess C1 is C1. And this is my unknown constant 1 and my unknown constant 2. They're part of my general solution, and it's okay if they stick around as long as I don't have initial conditions to solve them. When I get to n equal 2, my answer can use my r's, but I can't specify any new unknown coefficients because it's a second order problem. And this one's pretty easy because it's just that C2 equals 0 we have. And I'm never going to be able to use R1 again because all it told me about was C2. Now, when I'm trying to find N3, I know that I'm going to have to use this equation. And what I'd like to do is actually write it out in terms of not n, because it's kind of confusing that C3 is when n is 3, but that doesn't line up with what n would be in this equation. So I'm going to rewrite it as ck plus 2 is equal to ck minus 1 over k plus 2 times k plus 1. Then using that notation, if I want to reach 3 in here, that's going to be when k equals 1. I'm going to need way more space. That's going to be when k is 1 for that second relationship. Then C1 plus 2 is C3. So plugging into my formula, I know it's going to be C1 minus 1 divided by 1 plus 2 times 1 plus 1, or C0 over 3 times 2. don't simplify these things that you're multiplying together, because eventually we want to find a pattern, and if you start multiplying numbers, they get really big and it's hard for you to tell like what made that number. But if I start saying lots of multiply 3's, I know that's part of my pattern, so I want to keep it this way. And then I just keep going. So I've got n equals 4 is C4. That's going to be when I plug in 2 to k plus 2. So that's C2 minus 1 over 2 plus 2 times 2 plus 1. That's C1 over 4 times 3. And so somehow when I'm moving up in the ends, I'm like always dividing by two numbers that are sequential, and they're getting higher. So I like that about my pattern so far. And then for C5, that's going to be when k is 3. So I'm going to look at C3 minus 1 over 3 plus 2 times 3 plus 1. That's C2 over 5 times 4. But C2 isn't one of my two unknowns. I can only have things in terms of C0 or C1. So then I roll back up and I find, oh, I need to plug in 0. So C5 is just 0. I'm going to go ahead and move to my next slide here. So if you're still writing that last one, take a second, go ahead and pause. But we're going to go on to n equals 6. So this is that case where k would be 4. To get 4 plus 2 is 6. So then C6 is C4 minus 1 divided by 4 plus 2 times 4 plus 1. That's C3 over 6 times 5. And C3 isn't one of my two unknown coefficients, so I have to go back. C3 was C0 over 3 times 2. I need to plug that in. And notice how I'm still not simplifying any of those numbers in the denominator. I want to see my C0 and I want to see every number I'm multiplying, because now I can see there's that sequential 6 times 5. I skip 4 and then I do 3 times 2. Some kind of pattern there, but it might take me more coefficients to start seeing it. So I do n equals 7. That means I do 5, so that 5 plus 2 gives me 7. C7 is C5 minus 1 over 5 plus 2 times 5 plus 1, which is C4 over 7 times 6. And I got to go back again. I'll come back to this page in a second. I know you're probably still writing. C4 was C1 over 4 times 3. So I get rid of C4. I want only C1s and C0s. I keep my 7 times 6. And I also need that 4 times 3 that came from C4. And then when I get to n equal 8, that's when k is 6. So I'm looking at C6 minus 1 over 6 plus 2 times 6 plus 1. That's C5 over 8 times 7. But C5 was 0, so this is another 0. So hopefully now you're starting to see that I have a pattern to my coefficients. I have one that depends on C0. I always multiply two numbers on bottom to whatever I had before. Like here, I would skip 7, and then I would move up and I would multiply 8 and 9. And then I have C1 and I follow the same rule. I skipped 5 before, so now I'm going to skip 8, and then I'm going to multiply like the next two biggest numbers, 9 and 10. And then I always skip a term for my C2 type term, C2, C5, C8. So some kind of pattern is emerging, even if you couldn't tell what that word was, it was emerging. What we want is y equal to c0 plus c1x plus c2x squared, so on and so forth, written only in terms of c0 and c1, my unknown constants. So for us, y is going to be equal to c0 plus c1x plus 0 times x squared was my c2, plus c0 over 3 times 2 was my c3. That means my next one was c1 over 4 times 3, x to the 4th. Then I had a 0, x to the 5th. Then for my 6th term, I went back to c0, and this is where I skip 1. Oops, sorry. Managed to switch pages on you. Skip 4, do 3 times 2, x to 6. I think I can fit one more. C1 comes next, and then that does 7 times 6, skip 5, 4 times 3, x to 7, so on and so forth. X to 8 term is 0, and next I would have x to 9, which would take me back to depending on C0. So usually what we want is to have C1 y1 plus C2 y2 for 2 unknown constants and 2 fundamental solutions. Or in this form, we're going to have y equal to C0 y0 plus C1 y1 because our 2 unknown constants are C0, C1. That's going to give us C is C0 times, and I'm just going to pull out my C0 type terms. So I've got 1 plus 1 over 3 times 2x cubed. I'm just ignoring the C0 because it's multiplied out front by everything. Plus 1 over 6 times 5 times 3 times 2 x to the 6th. And even though I didn't write it down, I know that my next one is going to be 9 times 8 times 6 times 5 times 3 times 2 x to the 8th, so on and so forth. And then my plus C1, and here I just look at my C1 terms. So they start with x plus 1 over 4 times 3x to the 4th. Sorry, that was x to the 9th because x to the 8 is one of those zeros, my bad. Plus 1 over 6 times 5 times 3 times 2 x to the 6th. And we didn't find it, but we know our next C1 term is going to be on x to the 10th. So it'll be 10 times 9 . Actually, we would skip 7. That would only take us up to 8. Sorry, I just copied down my C0 term here. I should be at C1. That 1 over 7 times 6 times 4 times 3 x to the 7. So I know my x10 is going to be that 10 times 9, skip 8, 7 times 6, skip 5, 4 times 3 times x to the 10, so on and so forth. And that's my solution. For some problems in this section, we'll actually be able to write a formula for these functions, but here they're kind of weird with those skipping numbers. So we don't have it. I do want to note that in this formulation, the bracketed functions here and here are our fundamental solutions. Which may have been obvious to you from us trying to represent it in this form, but I just want to make sure we're all on the same page about that's what we just found here. So I'm going to end this video, and in the next one we'll do the setup for a different example just so you get more practice with this.